Hello everyone, today we are going to dive into an interesting problem which is parallel courses tree, where we receive as input an array of courses and then we are supposed to find out what is the minimum time to complete all of the courses. Given that we have the time we need to allocate to a given course and we have dependency in between those courses, that means this course can be executed only after this one. So given those two parameters, how are we going to organize ourselves to solve it? So let us see some example. If you have this as example, you have the course 1, the course 2 and the course 3. Now the course 1 is actually going to take you 3 months. The course 2 is going to take you 2 months. But there's no dependency in between those ones, so you can do the 1 and the 2 simultaneously at the same time, and then only after those two has been done that you can do this, right? So if you are done with the first one, you cannot directly go with this because you also need to complete the second one before you start this. So given this, how are we going to organize ourselves to solve this? So before diving into the discussion of the approach, I really encourage you to subscribe. Do not miss what you are doing here, because here we are doing LeetCode daily hackering solution. So what will be our approach of solving this? For us to solve this, we are going to break it down into a more understandable process, right? So we have tasks, right? If a task has zero dependency, that means if it's linked to no task, that means we can immediately start the task. If the task has a dependency, that dependency is going to create a delay which is going to affect the finish time of the task. So basically that's the thing. So for instance, if we go like this, we have this task is actually the first one, so it has a delay of 0, so we can immediately start applying this. The same for this and the same for this. But this, we cannot directly apply this. It has some few dependencies which are 1 and 2. So the finish time of this task will actually be the duration of this time plus the delay, and the delay is actually equal to the finish time of his dependency. Is that clear for you? That means if you want to compute the finish time of a given task, is actually equal to the delay of the task plus the duration of the task, and the delay of the task is actually equal to the maximum of the finish time of all of its dependency. So given that you are aware of this, now how are you going to make it to be easy for you? For it to be easy to you, you need to create an array of dependency that we are going to call maybe dependency like this, and then you are going to put it this way, like, okay, one, we have a dependency of there's no dependency, so it's an empty array. Two, we have no dependency, so it will be an empty array. Three, the same, we have no dependency, so it will be an empty array. But now 4 has dependency. What are the dependency of 4? The dependency of 4 are actually 1 and 2, right? So 4 has dependency which are 1 and 2. Sorry for the writing. 1 and 2. And then 5 has dependency, right? And what are the dependency of 5? They are actually 4 and 3. 4 and 3. And the last one, 6 has a dependency which is just 1. 6 has a dependency which is 1. So if you are able to represent your dependency this way, what you're going to do is that you're going to say the finish time of the element at position 1 is actually equal to the duration of 1 plus the maximum of all of its dependency. Finish time of 2 is actually equal to duration of position of element 2 plus the maximum of all of finish time of dependency. So by thinking this way, you are able to come up with something easy to implement, right? Now, how are we going to implement such approach? So the implementation of this approach will be as follows. So we are going to have a function that we are going to call compute finish, which is going to help us to compute the finish time of a given task. And then he's going to behave like this. He's going to say if the finish time is actually let me explain it a better way. So basically, for you to complete the finish time, you need to just have this. You need to have a delay which is starting at 0, and you need to loop through all the dependency. For each of the dependency, the delay will actually be the maximum of the previous delay and the compute finish of those dependency. So you do agree with me that if you have 0 dependency, your finish time will just be equal to your delay, which is 0, plus your execution time. But if you have dependency, we need to compute the finish time of all of your dependency and take the maximum, and that maximum is going to be your delay, and that delay adding to your time will be your finish time. So basically, this is the part of the code which is responsible for this. But the issue is that by actually computing the delay, you call the compute finish many times. So you don't want to end up compute the same thing maybe 1, 2, 3, 4 times, because a dependency can be attached to many causes, right? That is why you think of having a memorization. So you think of having an array which is going to be used to keep the compute value. That is why we are adding this. So basically, the core logic is just this, but we are adding this just for memorization purpose. So whenever we find something, we add it to our memorization before returning it. So now we know how the compute finish works. So now that we know how the compute finish works, the next thing we need to have is this dependency. We don't know. This is actually the node. So if I want to compute the dependency of 1, is element 1. The array of dependency, we don't have it yet. The way it has been presented to us is not actually the way we want it to be, right? The way it has been presented to us, which is this way, is not actually the same like this that we want it to be. So we need to create this. That's why we create a global array dependency, and we loop through our relation and we create the dependency using the format we think it would be easier for us, right? Once we have it, now we just apply what we're just saying here. We just loop through the we just loop through the node, and you're gonna say for each node we just need to compute the finish time, which is actually equal to the compute finish of that node, the dependency of that node which has been built here, and the array time, because in the dependency we are going to use time to compute here, so we definitely need it. And then the finish time, because we want to perform memorization and we use the value that has been used here. So at the end of the finish time, the result just need to take the maximum of the finish time of the element that we just compute and the previous finish time, and at the end we just return the result. So basically, this is actually going to create a kind of array finish time where each element has the value of the finish time of that I would say that book or that course, and then you just return the maximum by applying this max iteratively. Whenever you're moving, at the end this result will have the maximum value of the array. So basically, this was my approach of solving this. Let me submit and see what it gives. Do you want my approach of solving this? I hope you do enjoy it. Feel free to leave me any comment. I'll be really happy to interact with you regarding this.